Just 7 hours after the death of Albert Einstein, the greatest mind of the 20th century, his brain was stolen. It wasn't done by a thief looking for money or by a fan who was desperate. It was done by a doctor with a scalpel and an obsession. Albert Einstein died on April 18, 1955, from an aneurysm in Princeton, New Jersey. It didn't take long for the organ that came up with E equals mc2 and changed how we think about space and time to be carefully taken out and taken away for science. If this strange fact has already caught your attention, please click the like button. It helps more people learn about the hidden parts of human knowledge. But here's the question that will bother you. What secret was science hoping to unlock from the very neurons that created the theory of relativity? What made a respected doctor who studies dead bodies risk his career and reputation to examine the brain of a man who explicitly wanted to be cremated whole? By the time you finish reading this book, you will learn the shocking truth about this strange 50-year journey of scientific obsession. You will also gain a new perspective on what true genius really means. Most importantly, you will learn how to develop your own genius. What they found in Einstein's brain is surprising. What they didn't find will change how you think about your own potential forever. The story I'm about to tell you isn't just about one stolen brain. It's about how people need to understand brilliance, how we often look for magic solutions in the wrong places, and the truth about where genius really comes from. Get ready to think differently about intelligence, creativity, and the biological basis of human achievement. Dr. Thomas Harvey was a doctor who studied diseases at Princeton Hospital. He was born in Louisville, Kentucky in 1912. He studied at Yale University, just like his great-grandfather, and graduated in 1941. By April 18, 1955, Harvey had built a respectable career in pathology, but he was about to make a decision that would define the rest of his life and ignite one of the most controversial chapters in the history of neuroscience. When Einstein's body arrived at Princeton Hospital, Harvey was the doctor who examined it. What happened next was both very bold and somewhat unethical. Shortly after Einstein's death in 1955, Harvey removed and weighed the brain. It was 1230 grams, but here's where the story takes a disturbing turn. Harvey made this decision without getting explicit consent from Einstein's family, and certainly against Einstein's own expressed wishes to be cremated intact. Harvey said he was curious about science. He and many other scientists of his time thought that Einstein's amazing brain must have left some kind of evidence in his brain tissue. In the 1950s, most scientists thought that genius could be measured and explained by biology. Harvey thought he was about to solve one of the world's most important mysteries: what makes someone smart? After cutting the brain into 240 pieces for research, Harvey learned that 1950s brain science was not good enough. But Harvey wasn't going to let that stop him. He took pictures of the brain from different angles, creating a detailed visual record. He then began the careful process of cutting the brain into hundreds of small pieces, each of which was preserved and catalogued. Some of the pieces were embedded in celluloid, while others were embedded in paraffin. This created a library of Einstein's neurons. Harvey believed that this would revolutionize our understanding of human intelligence. The distribution started almost immediately. Harvey sent samples to researchers around the world. He believed that working together, scientists would eventually find the answers he sought. Scientists around the world, including in Philadelphia, California, Argentina, and beyond, studied the brain tissue. Each researcher hoped that a close look would show the differences that made Einstein. But the 1950s was not the time of advanced brain imaging, advanced molecular biology, or our current understanding of how the brain changes. The tools that Harvey and his colleagues had were very basic compared to what we have today. They could measure cell density, examine tissue structure, and look for gross anatomical differences, but their instruments couldn't see the subtle neural networks and synaptic patterns that might truly distinguish a brilliant mind. Harvey didn't expect the journey to last for decades. Harvey, who died in 2007, performed the autopsy on Einstein in 1955 and kept some of Einstein's brain for scientific study. For the next 40 years, Harvey would carry pieces of Einstein's brain with him as he moved from job to job and city to city. He kept the specimens in jars, boxes, and eventually in a cooler in his basement. Instead of making him a famous scholar, the brain caused him to fail. The weight of his decision began to ruin Harvey's career. The controversy surrounding the unauthorized removal damaged his reputation. He lost his job at Princeton Hospital. His marriage suffered because of his obsession. But Harvey didn't give up. He was sure that he was protecting something very important, the physical remains of the most significant intellectual achievement in human history. The ethical problems with Harvey's actions still affect us today. Was his scientific curiosity worth stealing from graves? Can the desire to learn justify going against a person's wishes? As time went on, these questions became more complicated. Harvey had promised to make some very important discoveries, but he didn't do that. What started as a search for scientific knowledge turned into something more concerning. A man's constant effort to justify a single, sudden decision made after the death of a great mind. As time went on, scientists around the world looked closely at their samples. They started to see a pattern, but not in Einstein's brain tissue, but in the nature of the findings themselves. The first major study wasn't published until 1985, 30 years after Harvey's important decision. A 1985 study published in Experimental Neurology examined Albert Einstein's brain after it was stolen. The study found that Einstein's brain looked physically different from other people's brains. At first, the discoveries seemed hopeful. Some parts of Einstein's brain had more glial cells than average for a man. Glial cells support and nourish neurons. Researchers thought that the greater number of glial cells per neuron might indicate that the neurons in Einstein's brain had an increased metabolic need. This means that they needed and used more energy. Additional studies revealed more interesting differences. Dr. Sandra Whiteson noticed that Einstein's Sylvian fissure was largely absent. The Sylvian fissure separates the parietal lobe into two parts. Without this dividing line, Einstein's parietal lobe was 15% wider than the average brain. A study of his brain showed that the top and back parts of his brain were actually 15% larger than average. Researchers found more problems. Neuroscientist Sandra Whiteson reported an unusual configuration in the folds and grooves of Einstein's parietal lobes, suggesting they may have developed earlier in life than usual. Each finding seemed to support the idea that Einstein's genius was caused by biology, and that his extraordinary abilities were literally written into the structure of his brain. But here's where our story takes a big turn. As more detailed studies became available and more researchers examined the evidence, the situation became much more complicated and less clear-cut than Harvey had hoped. First, there's the basic problem of how big a sample size we need. Scientists compared Einstein's brain with the brains of other people. Sometimes they compared it with as few as 11 other brains. In real scientific research, you need a lot of people to take part to be able to say something meaningful about the results. Any brain might show unusual characteristics for reasons having nothing to do with intelligence or creativity. Second, there's the problem of correlation versus causation. Even if Einstein's brain was structurally different, how could researchers prove that these differences caused his genius rather than resulted from it? Our brains are very flexible. They change based on how we use them. Math is so hard that it might change your brain. The enlarged parietal lobes might be a result of Einstein's thinking patterns, not the cause. Third, and perhaps most shocking, is what Harvey's photographs of the brain showed. They revealed that Einstein, who was known for having a large brain, actually had a relatively small one. Einstein's brain weighed 1230 grams, which is actually smaller than the average male brain. If brain size determined intelligence, Einstein should have been ordinary, not extraordinary. But the most troubling part of this whole situation isn't scientific. It's philosophical and deeply human. People are obsessed with Einstein's brain because it makes them uncomfortable. We really want to think that great accomplishments come from some special biological gift, like a lucky genetic lottery ticket. That explains why some people change the world while others struggle with everyday problems. This desire is everywhere in our culture. We examine the habits of successful entrepreneurs are looking for a unique method to help them reach their full potential. We study how great artists work to find a way to be more creative. We study the brains of geniuses, believing that there is a plan for how smart people think. But this approach doesn't really understand what human achievement is. Here are some of Einstein's own words about his success. "I'm not the smartest, but I can solve problems." This wasn't false modesty, it was insight into the real source of his achievements. Einstein's genius wasn't primarily biological. It was methodological and philosophical. He dealt with problems in a different way than other people his age. While other physicists accepted Newton's ideas about how things move, Einstein questioned them. While others worked within existing frameworks, Einstein imagined new ones. While others used the tools they already had, Einstein came up with new math to describe reality. The tragedy of Harvey's quest isn't just that it went against Einstein's wishes or took decades of scientific effort with unclear results. The real tragedy is that it distracted us from the qualities that made Einstein extraordinary. He had a relentless curiosity. He was willing to question authority. He could think in visual and mathematical ways, and he was persistent when faced with problems that seemed unsolvable. These qualities aren't found in the ratios of glial cells or the dimensions of the parietal lobe. They're habits of mind that can be developed, perspectives that can be adopted, and approaches that can be learned. But as long as we're searching for genius in stolen brain tissue, we're not developing it in our own thinking. People are obsessed with understanding what makes someone or something great. This shows that they are afraid of being great themselves. They think that being great means changing the way they think and deal with challenges. It's easier to believe that Einstein was born with a special brain than to accept that his genius came from many years of focused thinking, careful observation, and never-ending questions about assumption. After 70 years of study, hundreds of research papers, and countless hours of microscopic examination, what have we truly learned from Einstein's stolen brain? The answer is both disappointing and liberating. The differences in his brain, like the increased glial cells, the unusual parietal lobe structure, and the missing Sylvian fissure, don't tell us much about why he was so smart. Einstein's brain was similar to the control brains in how many neurons and glia there were in the other three areas studied. Even the most significant findings are only connections, and many have been questioned by later research. But the fact that we haven't found a genius gene or a brilliance blueprint in Einstein's brain isn't a failure. It's a revelation that should fundamentally change how we think about human potential. The most important lesson from Einstein's brain isn't what scientists discovered in those 240 carefully preserved pieces. They didn't find a magic biological explanation for extraordinary achievement. Einstein's brilliance wasn't an inherited trait that set him apart from everyone else. It was the result of certain ways of thinking and solving problems that anyone can learn. Think about what made Einstein so revolutionary. He didn't just have a good memory or be good at math. He had the intellectual courage to question basic beliefs that everyone else accepted as true. When scientists all believed in the idea of absolute space and time, Einstein asked, "What if they're not absolute?" When scientists studying matter and energy accepted that gravity and special relativity cannot be reconciled, Einstein imagined, what if gravity isn't a force at all, but rather a bend in the fabric of space-time itself? This way of thinking has nothing to do with how your brain is physically structured. It has to do with the mental habits you've developed over time. Einstein had what some call productive skepticism, which means he was able to question common beliefs without being too negative about everything. He developed conceptual flexibility, which means he could imagine familiar things in completely new ways. He had a strong desire to keep asking questions, even when the answers seemed impossible. These qualities can be developed. They need practice, dedication, and often the willingness to appear foolish while exploring ideas that are different from the usual ones. But they don't require a special brain structure or unique genetic makeup. The story of Einstein's stolen brain also shows that it's dangerous to look for simple explanations for complex things. We want genius to be biological because that makes it seem rare and unchangeable. If Einstein succeeded because of his unique brain, then the rest of us are off the hook. We can't be expected to achieve similar breakthroughs because we lack his neurological advantages. But this easygoing story stops us from reaching our full potential. If we believe that creativity, insight, and new ways of thinking require special equipment, we won't invest in developing the software, the mental habits, and approaches that actually drive innovation. The most important lesson we can learn from this is that Einstein's brilliance came from his approach, not his biology. He succeeded not because his brain was wired differently, but because he thought about problems in a different way. He asked different questions, made different assumptions, and continued even when things got hard, which would have made others give up. This means that the path to your own breakthroughs, whether in science, art, business, or any other field, isn't hidden in your genes or brain structure. You can develop this skill by cultivating specific mental habits. These include questioning assumptions, thinking in analogies and visual models, persisting through confusion and uncertainty, and maintaining the kind of playful curiosity that sees problems as puzzles to be solved rather than obstacles to be avoided. The real tragedy of Harvey's 40-year obsession isn't just the ethical violation or the scientific dead end. Researchers were studying brain tissue to find the secret of genius, but they were ignoring the actual secret that Einstein revealed through his words and actions. Genius has more to do with how you choose to use your brain than with what your brain looks like. So what should you do with this knowledge? Stop looking for the biological secret of success outside of yourself and start looking inside yourself at your own thinking patterns. Have the courage to question what others accept. Keep going with difficult problems even when it feels like you shouldn't. Try to think in new ways that might help you solve old problems. Einstein's stolen brain taught us that we've been looking for genius in all the wrong places. The source of new ideas isn't in the brain tissue that can be cut up and studied. Anyone willing to think differently, question deeply, and never give up in the pursuit of understanding can have it. Perhaps the most important secret of Einstein's brain wasn't in its cells, but in the deep understanding that the keys to unlocking your genius lie not in studying another's mind, but in developing your own. The next time you face a problem that seems impossible, remember that the man who changed our understanding of the universe didn't succeed because of his unique brain cells. He succeeded because he dared to think differently than everyone else. People can think in revolutionary ways, and they don't have to be very smart. It's waiting to be discovered by you. You can do this by asking questions, being persistent, and seeing the world in new ways. The mind that came up with relativity is gone. It's spread across different labs and is no longer with us. But anyone brave enough to question, curious enough to wonder, and persistent enough to keep exploring when others give up can understand those insights. Your intelligence isn't determined by your genes. It's waiting for you to ask another question, have another insight, or be willing to see things differently than everyone else. The secret was never in Einstein's stolen brain. It was always in your own magnificent, untapped potential. If this video made you think differently about reality and your own potential, please like and subscribe for more videos about the human mind. The most important discoveries are still to come. They are waiting for people who are willing to question what most people accept as true.